Hello everyone. Today our discussion topic is National Quantum Mission. This will be important for the upcoming APSC interview point of view. And you also know that one question on this topic already asked in the APSC mains examination. National Quantum Mission to scale up research and development, leverage India into leading nation in the area. First, shortly see the main 3 points. National Quantum Mission to seed, nurture, and scale up scientific and industrial research and development and create a vibrant, innovative ecosystem in quantum technology. Yes, because quantum technology is a kind of emerging technology which is in current trend. It targets developing intermediate scale quantum computers with 50 to 1000 qubits in 8 years, quantum communication with complete quantum key distribution. Mission can provide a great fillip to the invention of, this should be filled up, okay, to the invention of new products and services, as well as create world-class startups, HRD, and international collaboration. This is the main 3 objective of this National Quantum Mission. So this mission received cabinet approval from 2023-24 to 2030-31. The mission aims to scale up scientific and industrial research and development for accelerating quantum technology-led economic growth and leverage India into a leading nation in the area. Okay, what is the National Quantum Mission? So it will, you just got it that from this picture itself, it is clear that it will be implemented by Department of Science and Technology under the Ministry of Science and Technology. And it planned for 2023 to 2031. Okay, so this is the duration, 2023 to 2031. To aims to seed, nurture, scale up scientific and industrial research and development and create a vibrant and innovative ecosystem in quantum technology. Then with the launch of this mission, India becomes the 7th country to have a dedicated quantum mission after US, Austria, Finland, France, Canada, and China. So now India becomes the 7th country after US, Austria, Finland, France, Canada, and China to launch a dedicated mission on quantum computing. Now, what are the salient features of National Quantum Mission? First of all, it will target developing intermediate scale quantum computer. See, intermediate scale, okay? Intermediate scale quantum computer with 50 to 100 physical qubits in the 5 years and 50 to 1000 physical qubits in the 8 years. So first 5 years, its aim is to develop 50 to 100 physical qubits, and then next 8 years, 50 to 1000. So in 8 years, 50 to 1000, in 5 years, 50 to 100. Then just like bits, 1 and 0 are the basic units which our traditional computer process information. But in case of quantum computer, the bits are qubits or quantum bits. They are the units of process by these quantum computers. Got it? In our traditional computers, what we use? 1 and 0, 0 and 1, right? And in case of, and these are known as binary bits, 1 and 0. But in case of quantum computer, they will be quantum bits, qubits to process the information. This mission will help develop magnetometers with high sensitivity for precision timing, like atomic clocks, communications, and navigation. So this will help to develop magnetometer with high sensitivity. Then it will support design and synthesis of quantum materials like superconductors, novel semiconductor structures, and topological materials for the fabrication of quantum devices. So it will also help us, in short, it will also help us to design and develop the superconductors. You just see superconductors. Okay. And semiconductors also structures are there. And why? Because for the fabrication of quantum devices. Then this mission will also help to develop satellite-based secure quantum communication between ground station over a range of 2000 kilometers within India. This is very important feature. See, this quantum computing helps us in quantum communication, that is a kind of secured one. And also you can see here the range is over a range of 2000 kilometers. Then long distance secure quantum communications with other countries also, intercity quantum key distribution over 2000 kilometers, then multi-node quantum network with quantum memories. Then 4 thematic hubs, T-hubs, would be set up in top academic and national research and development institutions on the domains of quantum technology. And what are they? Quantum computation, quantum communication, quantum sensing and metrology, and quantum materials and devices. Remember, 4 thematic hubs are quantum computation, quantum communication, quantum sensing and metrology, quantum materials and devices. They would be set up in top academic and national research and development institution. Now, if you compare quantum computing with classical computing, like quantum computing versus classical computing, you see the comparison here. Quantum computing calculates with qubits, which can represent 0 and 1 at the same time. See, 0 and 1 at the same time can be processed or can be represented with the help of qubit. But in case of our traditional computer, like this laptop I'm using, like the computer you are using or laptop, whatever you are using, it calculates with transistors that can represent either 0 or 1, but cannot be 0 and 1 at the same time, both at the same time. Got it? So just remember that 0 and 1 both can be represented at the same time using quantum computer, but 0 and 1 cannot be represented at the same time. Both cannot be represented at the same time using our traditional computer. Then power, in case of quantum computing, power increases exponentially in proportion to the number of qubits, but power increases in a 1:1 relationship with the number of transistors in the case of traditional computer. Then quantum computers have high error rates and need to be kept ultra cold. That is a kind of, you see, disadvantage, because this quantum computer should be kept in ultra cold, normal atmosphere, normal temperature. It cannot bear, it cannot tolerate, because it will give high error at such normal condition. It should be kept in ultra cold. But in our traditional computers, we are keeping it at any temperature, right? Classical computers have low error rates and can operate at room temperature. Then in which situation these quantum computers will be more suited? Yes, they will be well suited for tasks like optimization problem, data analysis, and simulation. And in case of traditional computers, most everyday processing is base handled, right? Everyday processing. Suppose you are working for your office files, Excel works, worksheet works, or traditional kind of documental work, then in such cases, classical computers work fine. Now, what are the advantages and disadvantages of the quantum computing? First, we see the advantage. Quantum computers are so fast that traditional computers can never match. That is the fast you have to remember about quantum computer, that they are very, very fast, very, very fast in comparison to the traditional computers. No matter how complex the problem is, quantum computing allows a solution. Obviously, it will try to solve a very complex problem. Then, given the complexity and speed the quantum computing can achieve, quantum computers can run complex simulations also. But disadvantage, you see now, just one disadvantage I already told you, that should be kept in ultra cold environment, right? Quantum computers are difficult to build and require unique components, expensive tech, and massive cooling system. Depending on the nature of qubits and quantum mechanics, environmental factors can produce a lot of errors. Quantum computers have the potential to find revolutionary solution, that is okay, but only specific area, only in specific areas and for specific tasks. These are the disadvantages of quantum computers. Well, let's talk about the significance of this National Quantum Mission of India. National Quantum Mission is going to give India quantum jumps in this arena. India will be the 7th country to have a dedicated quantum mission after what? US, Austria, Finland, France, Canada, and China. So beyond its significant civilian applications in governance and industry, quantum technology is the newest frontier in military communication and has the potential to be a game changer in complex areas, because quantum communication is highly secured. One can be used in just defense-related communication. The National Quantum Mission will aid India's nascent efforts to compete with China, because you see that China is already there in the list, right? Of those first 6 countries. Now India becomes the 7th, right? So National Quantum Mission will aid India's national efforts to compete with China in the field of quantum communication technology, which the country has said to have achieved significant advancement. So we have to work on this National Quantum Mission in a dedicated way to have to address the competition from the China side, right? A country with an advantage in quantum communication can cripple any enemy country by hacking its data and communication networks. That is again a threat from the China side, right? So to address those things, we also should have developed such advanced technology in quantum communication, and that will be possible through this National Quantum Mission. Now, a country with quantum communication can keep a country's electricity, aviation, defense, energy, and other critical infrastructure safe from attacks by an enemy country. You see, in case of Bombay, I think in Bombay, yeah, recently we got the news of a cyber attack in the electricity grid. So that implies the light fall for the whole city, light being shut down by those cyber attackers. So we need more secure such digital infrastructure should be more secure if they are linked to the physical infrastructure, because then that becomes critical infrastructure. So to safeguard such critical infrastructure, we need a highly secured mechanism, or you can say technology, and that is possible through quantum communication. Then benefits to government scheme, this mission will also provide a boost to other priority schemes like Digital India, Make in India, Stand Up India, Skill India, and achieving the Sustainable Development Goals. So in this case, I would like to ask a very small question to you. If you're listening carefully, if you're going through my previous lectures carefully, then tell me, what are those sustainable development goals that you can, by yourself, from your own analysis, link with this quantum national mission? Means if quantum national mission means national quantum computing mission or national quantum mission, if this is successfully implemented, then it will means fulfill which of the sustainable development goals. Okay, so mention the answer to comment. Now we see the significance. Let's come to the concerns. So as a civil servant, we have to talk both positive and negative. We have to look at the both positive and negative sides, right? So concerns about the quantum technology. First of all, quantum computers are extremely expensive. The material used to create them can be costly, and many researchers believe that this cost may never be recovered. Then second thing, quantum computing is extremely difficult to program and control. It requires a high-level understanding of complex quantum principles. So for the common computer programmers, I think it will be very difficult to understand such complex quantum principles, because it will require extra training to understand those principles, quantum principles. Okay. Yes, if it will be means they will be given training, then they can handle this. Then when it comes to interference from the outside world, such as temperature variation, magnetic fields, and vibration, quantum technology is extremely sensitive. You cannot put those quantum computers in the room temperature. They should be kept in ultra cold conditions. Then a disruption in the current computer architecture is another possible drawback of quantum computing. So a disruption in current computer architecture will become one drawback of such quantum computing. Then its reliance on entanglement and superposition, according to many experts, makes it susceptible to assault by hackers who are familiar with the technology. If some hackers are smart enough to deal with this entanglement and superposition. Yes, entanglement and superposition means with those qubits, qubits can exist in different states. If we superimpose those states, then we can have a different output. If those hackers will be able to hack those things or able to crack down those superposition or entangled features of the quantum computing, then they can do anything. So that is again a threat. Well, let's come to the way forward then. First of all, we need more funding, robust funding, ensure sustained and adequate funding for the mission to support research, development, infrastructure development, and talent acquisition. Yes, all are important. R&D is important. Then infrastructure building is very, very much important for the quantum computing mission to be implemented properly. Then talent acquisition, because we, as I just told you, that it needs to understand complex quantum principles. So we have to hire those people, we have to train those people, then only the work on this quantum mission is possible. Then research collaboration, foster collaborations between academia, research institution, industry, both domestically and internationally, right? Slowly the you can say subjects on quantum computing should be included in the degree or higher higher educational program, so that they will cope up with those issues and they can go for some research on this particular area, right? Then accordingly scholarships should be given to work to those students who want to work on this particular area. Then skill development, focus on capacity building and skill development programs to nurture skilled workforce in the quantum science, engineering, and technology. Establish training initiatives, educational programs, and center for excellence. Yes, center for excellence on quantum computing is very much needed. Only few institutions are having current this year. If you go to the institute, only few institutes have this center of excellence. So we need to set up more such centers of excellence to develop talent and expertise in the quantum computing field. Then infrastructure development, already told you, right? Such very good infrastructure needed to maintain such ultra cold condition. Then regulatory framework should be there. Establish robust regulatory frameworks and policies to address legal, ethical, and security concerns to the quantum technology. Yes, because if such a advanced technology is there, we need some kind of framework to deal with the ethical issues that may come as a outcome of such technology, as in misuse of such technology, right? So we have to have such regulatory framework. Then industry engagement should be there, encourage industry participation and engagement in quantum technology initiatives, right? Then international collaboration should be there with those, India becomes the 7th country. We already have 6 countries which are having such dedicated quantum missions, right? So we have to collaborate with them, strengthen the international collaboration and partnership in quantum technology, establish network with leading global institutions and organizations to exchange knowledge and share resources and collaborate on the research project. And then public awareness and outreach is very much important. We have to increase the public awareness about the potential of quantum technology and its impact on various sectors. For that, some kind of outreach program should be conducted. Okay. Then how can we conclude? Because, although some disadvantages are there, but still this is a very advanced technology. And if the time has come for a technology, then we cannot stop it. At most we can postpone it, but we cannot stop a technology whose time has come, right? So we have to adopt that. And National Quantum Mission is a way to adopt it in an efficient way. National Quantum Mission can take the technology development ecosystem in the country to a globally competitive level. The mission would greatly benefit communication, health, financial, energy sectors, as well as drug design and space applications also. Yes, you see, despite of some kind of disadvantage, but the first advantage this type of quantum computers have, that they're very, very fast. Right. And at a good environment, at its required environment, it can work flawlessly. right? It can solve very complex problems and would help for different highly complex situations like space applications. Then also give us economically benefit. Means economically benefit in the sense that this we can design different technology that will be helpful for exporting to other countries, right? So it will help, or it will give benefit in communication, health, financial, and energy sectors, dark design, space applications. And it will also provide a high, or you can say huge push to national priorities, like, our missions, some missions: Digital India, Make in India, Skill India, Stand Up India, Startup India, Self-Reliant India, Sustainable Development Goals. These things can be easily what I can say that made successful if national quantum mission can be successfully implemented, because it will help us to implement these other missions in a prioritized way. Okay, so Digital India, Make in India, Skill India, Stand Up India, Startup India, Self-Reliant India, Sustainable Development Goals, all these things already we discussed. I hope you can relate this topic with them. Yeah, so why this topic is important? Obviously, this is a recent topic. And also, this year, Nobel Prize in chemistry awarded for quantum dots. Remember, Nobel Chemistry Prize awarded for quantum dots that bring colored light to screen. Okay, so depending on the different number of dots, so you will have a different color. Well, prize awarded to 3 scientists credited with bringing color to nanotechnology. See, so different nano means quantum dots. They used to in QLED screens. Even you can see in the Samsung those LED screen advertised. That is known as QLED, means quantum LED screens. You can see different colors are possible through that. And then applications are like in medical imaging also. In many fields, the applications are there. So that's why this time chemistry Nobel Prize being given to a technology based on quantum and quantum dots. Okay. So I hope it is sufficient for today's discussion. Any more you would like to discuss on quantum mission, quantum computing, you can just comment me. So this is, again, I am telling you, very important for APSC interview perspective. Okay. Thank you. Bye-bye.